log. I know that looks weird here. I use this the L like this. The natural log of 4 times m cubed times n to the 5th. It says to expand this. So this has been simplified. So here's how I would do so. I would break each one of these down into factors, which I've started to do, except for I did not write that 4 is equal to 2 times 2. So you could just say 2 squared. So we're saying what is, how can we break down ln of 2 squared, and I probably should have parentheses around this, times m cubed times n to the 5th power. Well, I could say that is equal to ln of 2 squared plus, because the product property says one logarithm with products or factors multiplying is equal to multiple logarithms adding. Natural log of m cubed plus, again, natural log of n to the 5th power. Now, the power product, or the power property says I can move my powers in front. So it'll have 2 times the ln of 2 plus 3 times the ln, natural log, that's what that stands for, of m, plus 5 times the natural log of n. And this here would be my expansion. So here's another one. This time we need to break it down into factors. These are not 2 factors. This is technically 1 factor there. And down here we have 2 separate factors for the denominator. All of this will make up 1 parenthesis or 1 logarithm, but we're going to break it down. So first thing I'm going to do is use the quotient property, which says that a log with a quotient is equal to 2 logarithms subtracting. So I would first have the numerator, the log of the numerator, minus the log of the denominator. Okay, and I'm actually going to say the 4th root of x, that's going to equal to x to the power of 1/4, because it's the power of 1 there, and you divide it by 4. That's where that comes from. I'll change the color and put a little 1 there so you can see. Now, so we're going to move on to the next step, and I'm going to say this is the same thing as, I can't break this down, it has no powers, so that's going to stay the same. That's already the simplest factor it can become. But this logarithm is not. These, you can see, are multiplying. Now, to break this up, this whole logarithm is part of a subtraction. We need either 2 logarithms subtracting, or I need to just put this all in parentheses together as I break it up. And that's probably the easier way, is to say log of 3 plus log x to the 1/4. So let me explain why I did this. These 2 logarithms are multiplying here, and the factor is multiplying, and so it would become 2 logarithms adding. However, they together, as factors, make up a denominator, so they need to be subtracting overall. So I can distribute the negative through, or I could leave it like this. This last step, I will distribute it through, and I'll also move this to the front. So I'll use the power property here, and I'll just distribute the negative through. So the best way of writing this answer would be 2x minus 3 minus the log of 3 minus 1/4 the log of x. So I distributed that there, and I moved that 1/4 to the front. And this would be my expansion. Now you go ahead and try this one. I would really recommend you try it and make sure that your answer matches up.